So yes, that was, of course, rational. And we talked about what it is. What about this guy? You have it right in front of you. What is D?
Bracket -2, bracket power 4.
Yeah, so what category does it fit into? I'm glad everyone can read, but what is the category that it fits into? It is indeed an integer. Is it anything else? Sarav? It is whole, and it is natural, and it is rational. So the smallest group, and nobody has answered that question yet. Why do I keep doing air quotes for the smallest group? Because it's not really the smallest, because they're all infinite. This is, of course, 16, which makes it natural. Because -2 to the fourth is -2 times -2 times -2 times -2. And we've already done a unit on exponent, or half a unit on exponent, so that shouldn't have tricked anybody. What about this guy?
So would integers also, like, if we were kind of integers, that would still work, right?
No, because I want the appropriate category or categories. The only reason I'm not writing them all is because at this level I expect you to know that if it's natural, it's everything else. So what about 9? Natural, of course, because we would hit it if we started counting like in kindergarten. And F is tricky because we never actually wrote it down. I just talked about it. What is F? Nope. Nope. Pardon me? No. You can't have a negative square root. Imaginary. Because, of course, you cannot have a square root of a negative number. Because a square root has to be 2 of the exact same factors, yes? And there is no way to multiply any 2 things that are the same to get a negative number. And, of course, this one is a little bit tricky because how does it appear? It doesn't stop because there's 3 dots. Yes? It could stop later on, and it could, Avnor? It could not stop, but so what category would you put it in? It appears rational. Why must I add that appears? You do not know if the 374th decimal place might be a 6. Right? What if it was like that? Now what is it? Rational. 100% rational. Okay? Okay. And, this page. Explain. The answers are over here. I don't care about the answer. I want the explanation. Is this number right here, which is what shows up on my calculator, but what I have written there, what is that? Rational, just like the answers say. I don't care about the answer. Why is it rational? Because the decimal ends. When you write it out, the decimal has to end. Because none of us are going to go lock ourselves in a cave in the Himalayas and continue to write this decimal until the end of time. Because that's how long it would take to write that decimal out. Does everybody understand that? Excellent. Now, the question then comes to this one. The answer here says it is irrational. How can that be irrational when it's shown right there? Pardon me? The decimal ends only because the screen ends. If that calculator screen stretched out to infinity, how many numbers would be on it? Infinite numbers. Would they ever repeat? Yeah, we do. Would they ever repeat? No. Would they ever end? No. The only reason this ends is the screen has ended. Okay, I know. So when you hit that button on your calculator, you need to be aware that that answer is not actually the square root of 150. The actual square root of 150, your calculator will not show it to you unless you have one of the fancy calculators that gives the answer as 5 square root sine 6. If you have one of those calculators, that is the actual answer to the square root of 150. And we will be talking about what that means in 2 lessons from hence. Okay? Okay. Let us move it along, cabbages. Thank you. I don't ask for much from you guys, really. I mean, really, have I asked for much? You haven't had a lot of homework. All I ask is that you laugh at the bad jokes. It's not a lot. All right. So, remember, we are using prime factorization here. So, without telling me what your tree looked like, does anybody wish to volunteer the GCF and the LCM of these 2 numbers? Because I already know it. Abby, which one would you like to offer us? The GCF is 12. Anybody wish to do the LCM? You sure? It's the tougher one. Okay, hit me. 360. All right. If you don't have that, then you need to ask right now. Abby.
Can you explain how to do it?
Which one?
The LCM.
Okay. So, we start always the same. 36, 6 and 2, 3 and 2.
How do you decide which?
No, sorry, not 6 and 2. Sorry, 6 and 6. I was thinking 6 squared. And 3 and 2.
Well, is the answer different if you choose?
Of course not.
Okay.
Because it doesn't matter how you divide it. And watch.
So you just pick a random one?
No, it has to be a factor.
Well,
I can't put 17 there.
Yeah, but I did like 4 and 9.
Okay, great. 4 and 9. 2 and 2. 3 and 3. See how it's the same? Because no matter how you start it, it ends up at the same prime numbers. That's why prime numbers are so awesome. So, of course, 36 is 2 squared times 3 squared. And then we go to 120. I, of course, would go with 12 and 10 because it ends in 0. 3 and 4, 2 and 2, 2 and 5. To get 2 cubed times 3 times 5. Now, this is weird because of the nomenclature. Nomenclature is how we call something. We are looking for the lowest common multiple. But that is weird in our brains because multiples are bigger, but we are seeking the lowest of those bigger numbers. Huh? Trust me. So, if we were to cheat, and we were to do this like Mrs. Bad Crumble taught you to find the lowest common denominator in grade 3, what you did in grade 3, if you had to multiply or add 1/5 and 3/4, is you did this, most likely. You went 5, 10, 15, 20. Then you went 4, 8, 12, 16, 20, and saw that. Right? Okay. Well, that's a bit of a pain in the butt when the numbers are gigantic, isn't it? So we don't do that anymore. But knowing that the lowest common multiple had to be bigger than both of them means you need numbers that are going to be bigger than both of these, right? So, if I need the bigger number and I take 2 squared, that's not covering my 120, is it? Because I know my number has to be at least 120. So I have to take the biggest exponent. Now when I come to here, I got to cover the bigger number. So I got to take the bigger number. So now everybody's good to there because that's the same as GCF. Right? Everyone's like, oh yeah, I got this, no problem. They're common. In my old-timey 1920s voice. So what I have now is 2 cubed times 3 squared, yes? Well, you're intelligent young people. What is 2 cubed? 8. What is 3 squared? 9. What is 8 times 9? 72. Is 72 a multiple of 120? No. So I must have to multiply by the other numbers that are there as well to get 360. Okay? Now, of course, you can check in your head. 360 times 10, or 36 times 10 is 360. 120 times 3 is 360. 3 is that's only the third multiple of 120, yes? So that's probably going to be the lowest common multiple. Right? Now, let's pretend you don't understand this at all. Could you list them all? Would I stop you? Could you go 36, 72, 108, 144, 180, 216? Could you list them? And then list 120, 240, 360, and eventually catch up? Yes. Why am I showing you this? Because prime numbers are powerful. You should start using them. Okay? Okay. So, all that being said, what is the LCM and the GCF of 18 and 24? Don't all answer at once. It makes it tough to choose. I hate it when I have to choose people because then somebody always feels that, well, I had my hand up. I deserve a chance to answer. So don't all put your hands up at once. Mantaj. You think the LCM is 72. You think that or you know that?
I know that.
Damn right you know it because it is 72. Because you did product of primes. You already had a turn. You go. The GCF is 6. Abso-smurfly correct. Everybody is good? All right. Oh, the Kool-Aid man is doing math in our class. 1 person, 2 people get it. 3 people get it. 4 people get it. The Kool-Aid man doesn't even do commercials anymore. But he shows up on Family Guy, isn't it? Isn't it on Family Guy where he busts through the wall all the time? Yeah, that's because Seth MacFarlane is my age. Every joke on Family Guy I heard 25 years ago, which is why grown-ups don't like that show. But you all think it's the funniest thing ever. Because it's not. Every joke on Family Guy is a dad joke. And if your dad told you, you'd be like, Dad, you're so lame. But if Seth MacFarlane tells it, oh my God, he's a comic genius. How is he so good at what he does? Man, I wish my dad were as funny as Seth MacFarlane. Oh, wait a minute, he is. So, 45 and 75. Who's going to GCF for me? Go. Yeah. Fit in. Who's going to LCM for me? Ooh, it's a scary one. Very scary. What is it? That's my vampire voice. What is it? Go. 225. All right. And, oh?
Can you go over how to do it one more time? I've done this like a million times. I just want to make sure.
GCF, because factors are smaller, you have to take the smaller number. Okay? So it's 3 times 5, so it's 15. Oh, you... Hulk smash. My pen stopped working, see? So, because this is such a piece of garbage, No, OG would be chalkboard, which I would love to have because they always work. No, what if my pen dies? What if my clown students continue to use their fingers to erase them? They're not running out of chalk in the world. They don't even, it's not even natural anymore. It's made. The good all right. So I had 3 squared, 45. Was 3 squared times 5, 75 was 3 times 5 squared. Yes?
Yes.
So factors are smaller. So I have to take anything that's common, and I have to take the smaller exponent. Okay? Now, you can believe me, or you can test this theory. If on GCF I take the bigger exponent, I get 9 times 25. That is 225. How can that be a factor of either of those? It is bigger than them. So you take the smaller exponent when you're GCFing. You take the small exponent. So that is 3 and that is 5 to get 15. Now, for the LCM, I still have 3 squared times 5, and I have 3 times 5 squared. Again, experiment with it. If I take 15, that is not a multiple of either of these things, because multiples must get bigger. So I have to take the biggest exponent. Now, the problem with teaching it this way first, I'm about to show you. That is 3 squared times 5 squared, which is 9 times 25, which is 225. Now, the problem with teaching it that way, because a lot of teachers teach it that way, they just say, GCF, take the smallest exponent. LCM, take the biggest exponent. Here's what when it becomes a problem. If I add 105 to this. Now, 105 is 3 times 5 times 7. So, I've got 3 squared times 5, 3 times 5 squared, and 3 times 5 times 7, correct? Now we have a problem because GCF, smallest exponent. So every kid says, Myers, I got you, smallest exponent. 3, 5, 7. And they write it down because they aren't thinking about what is actually happening. They think about what is the shortest thing I can possibly do so I can stop doing math and get back to TikTok. Okay? I know that's what you do.
No.
Yes, it is.
Yes.
No, I know this because as soon as I say go, the one thing none of you do is math in math class. So, you have to think about what is happening. That is why I don't teach this right away. Because there's a wrinkle. Smallest exponent of common factors. But over here, it's the biggest exponent of all factors. So, when I add that 105 to it, my GCF still is 15. Because I can't count that 7 because it's not common. Now, if I go to LCM over here, biggest exponent, okay, 3 squared times 5 squared is 225, right? But 105 doesn't hit 225, does it? Because it goes 105, 210, 315, right? So I have to remember to count everything. Now I got to multiply that by 7, which is 1,400, and 150 is 1,550, 1,575. That is the LCM of all three. Okay? You got to think about what is actually happening. Now, right now, a few of you, I heard it a few times when I did how this was 357 in my head that quickly. And then I heard a few of you when I got 1575 were like, it doesn't matter that I can multiply that fast. That doesn't matter. Because all of you would just pick up your calculator and do what? Multiply that. Now, sadly, some of you can't hit your calculator faster than I can do mental math. But that's another story for another day. Okay? Everybody good? All right. Now, computer's at a nice long rest. Nice long rest. Nice long rest.
Oh, yeah.
Okay. No. First, we'll do that battery thing where we shake the battery up a little and roll it around a bit, bounce it around a bit. Of course you remember doing that.
You made it worse.
No. Now, we'll try this one. Oh, that's spectacular. Well, that one's dead. I left you this page. I want for you, well, no, I didn't leave it for you. You're going to practice it right now because we have just gone over and redone this. I want you to do 6F, and I want you to do one of the 4 lists. So either C or D, C or D, and I want you to try 12, 13, and 22. And that's what we're going to do right now while I restart my computer a second time and have it fail again. Okay? Okay. I'm not being sarcastic. I am going to start my computer again, and it is obviously going to fail again.